Have you ever reviewed whether we're genuinely alone in the universe, or if there's something more to our reality than what we see? Imagine the possibility: what if the James Webb Telescope finally shows that we live inside a black hole? Join us as we explore more about this world, spreading a message that will make you question everything you thought you understood about the universe. So, what exactly are black holes? They're like something out of a thriller. Sure, you might have seen them in science fiction movies, but what's even more unsettling is that they're not just a fictional concept. According to well-informed experts, black holes in space are incredibly massive amounts of matter compacted into an impossibly tiny region. Imagine a star several times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been fascinated by black holes for a long time. Initially, they pondered objects in space so massive and dense that they could trap light. The most remarkable ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a giant star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they emit no light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Moreover, when a typical star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce strong beams of light, and even influence the formation of new stars in some regions while suppressing it in others. So, how do black holes come into existence? Picture this: stars, once bright and shining, meet their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something known as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these massive stars break down, something strange happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. Remarkably, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, it creates a cosmic nightmare that defies understanding. Researchers have been grappling with the scale of these cosmic phenomena for ages. Black holes come in two sizes, large and small. There's a bit of a misconception about them: small is relative when it comes to black holes. Exceptionally large black holes, remnants of giant stars, can be as much as 10 million times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an enormous number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are at the farthest end of the spectrum, millions, if not billions, of times larger than the Sun. These reside at the centers of massive galaxies, including our own Milky Way. They appear like a huge dead space, pulling everything toward them. The renowned physicist Stephen Hawking studied black holes throughout his life. His theories were well established, but some of his ideas proved difficult to confirm due to a lack of advanced technology. Yet now, there's hope on the horizon. A single revolutionary instrument is changing everything. It's called the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human ingenuity. Sure, We've launched other space telescopes before, and they've done their job well, but this phenomenal machine is on a level that's truly remarkable. The JWST makes the Hubble, which served us for a long time, look like a basic tool in the universe. The price tag of this astronomical wonder is a staggering $1 billion. Yes, you heard that right, that's a stunning number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with substantial contributions from over 300 universities. However, we shouldn't forget the risks that come with such an ambitious project. This isn't an endeavor for the faint-hearted. The JWST is venturing into an unknown world, pushing the boundaries of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made numerous incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after aligning and adjusting, the telescope is nearly ready for full operation. One of the most exciting parts of the James Webb Space Telescope was when NASA announced it had captured its first significant images of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light collected by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, in which 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory aligns the individual segments of the primary mirror, it will begin the process of stacking images on top of each other to form one clear view. Thanks to its advanced technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge once again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are challenging to detect due to how they interact with their host stars. Powerful observations can now closely study these planets, allowing scientists to analyze their atmospheres and explore the conditions necessary for life. The JWST's capabilities can help researchers better predict whether specific planets might be habitable. Beyond focusing on planet formation, scientists study these worlds to understand how matter is organized on a large scale, which in turn helps us understand how the universe has evolved, shaping the galaxies we see today into a variety of forms. One of the JWST's goals is to look back at the earliest galaxies to better understand how they evolved. Researchers are also working to determine how we got the variety of galaxies we see today and the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all: are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt, and guess what it has found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the soot of the universe. They're found everywhere from distant galaxies to comets in our own solar system. They're not just fascinating because they could form the building blocks of life, but also because they help scientists track star formation. When intense radiation hits these PAHs, they become excited and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are some hot, energetic stars nearby. But wait for the shocking twist: a prominent astrophysicist, Ismail Garcia Bernard from Oxford University, chose to investigate three intriguing galaxies, NGC 6502, NGC 731, and the Stepan Quintet, as well as NGC 749.